Hey everyone, welcome back to another video on SQL series. Today we are diving into the world of SQL and we'll explore what is data types and some of the commonly used data types. Let's get started. First, understand what is data type. The definition is that data type in SQL define the type of data that can be stored in a column of a database table. So this highlighted part says that what type of data we want to store in a column, that is decided by a data type. Okay, we'll get more clarity about data types with the help of below flowchart and some of the examples. So here we have database. Database contains tables and each table contains multiple columns. So here we have one table which having 3 columns in it, and if you can see here, each column is storing different type of data. Okay, the first column is storing integers only, that is 1, -5, 0, 5000, 10,000, etc. Second column is storing characters data, which may contains alphanumeric characters, some special symbols also. Example, email ID, name, etc. Okay, and the third column is storing date data. That means it can store some data values. That is like, if you can take the example, it's like 15th November 2023. It's a date and it is storing with the help of which data type? With the help of date data type. Okay, so these integers, Varchar2 and data are data types which indicates what kind of data the column can store. And that's why we need to understand the data type so that we can create columns of correct data type depends on the correct type of data. Okay. So we understood what is data type, and now we'll move on to the next part and we'll understand the commonly used data types in SQL. Okay. So we have integer, char, Varchar2, date, decimal, float, and timestamp, and we're going to understand each data type in detail. First, we have integer data type. In SQL, the integer data type is used to store whole numbers without decimal places. For example, 5, 10, 10,000, 5 lakh, etc. So we can store any whole number which don't have the decimal places. All these values we can store in the integer data type. Okay. Second point is talking about the range within our integer value can vary. Okay. So that is on scale. We can see here the left is lower limit and the right is upper limit, and our whole numbers has to be within this limit. Let's understand integer data type using below real world example. Consider a database table named as employees that stores employee information including their employee ID. The employee ID could be represented as integer data type. First, we'll create the employee table using this syntax. And after execution of this syntax, we'll be able to see the table structure like this. Now let's understand the table creation syntax. So in this example, the employee ID column is defined as an integer data type to store unique identifiers for each employee. Okay. So when inserting some data into this table, the employee ID column values would typically be whole numbers within the range supported by the integer data type. Okay. Let's see what type of data we can get under employee ID column. So we have this first syntax to insert some data into this table. So after execution, we'll see data is inserted like this in the respective columns. And we can observe here the integer data, that is 1001, is inserted into column, that is employee ID column. And likewise, we have another insert statement to insert another set of data. So after execution, we can see here the integer data, that is 1002, is inserted into employee ID column. Okay. Basically, employee ID values like 1001 and 1002 are integers within the supported range of integer data type. Okay. So these values uniquely identify each employee in the database. That is, each employee has some unique employee IDs that cannot be repeated because that's a unique ID and we can store that. Okay. Now move on to next data type, that is char data type. In SQL, the char data type is used to store fixed line character strings. This means that when you define a char column in a table, you specify a specific length for the data it can hold. Okay, and in that case, any shorter value will get padded or appended with spaces to fill the fixed length. So all these things we're going to cover further so that you'll get more understanding. Okay. The char can store alphanumeric characters like DD 1, 2, 3, symbols and special characters like @ hash, etc. up to a specified length of that char data type. Okay, so let's understand char data type using below real world example. Consider a database table named as product that stores product information, including the product code. The product code could be represented as char data type. First we'll understand the syntax to create the table. So we'll create the table using this syntax, and after execution of this syntax, we'll be able to see the table structure like this. Table has already created. So let's understand the table creation syntax. In this example, the product code column is defined as a char6 data type, indicating that it can store a fixed length string of up to 6 characters. Okay, the char data type is padded with spaces to the specified length if the length of the string is less than the set or fixed length. Okay, for example, if you define a char10 column and insert the string hello into it, it will be storing as a hello, okay, with 5 spaces added to fill the remaining 5 characters. That means 5 spaces will add the end of the string to fill that particular length of the string. Okay, so char is useful for the data that will always be certain or same length, such as postal codes or product codes. When you want the data to be uniform and occupy a consistent amount of space in the database. So that time we can make use of this char data type. So when inserting data into this table, the product code values would be fixed length strings. Okay, so let's see what type of data we can get under product code column. So with the help of below syntax, we can insert some data into this table. So after execution, we'll see data is inserted like this in the respective columns. And we can observe that the char data, that is P13579, is inserted into which column? Product code column. Likewise, we have another set of insert statement to insert another set of data. So after execution, we can see the char data, that is P98765, is inserted into product code column. Okay, so basically here the product code values, that is P13579 and P98765, are both 6 characters long, as specified by the char6 data type that we have mentioned at the time of table creation, and any trailing spaces are automatically added to make the strings of uniform length. Got it? This ensures that consistent storage and retrieval of data. Now we have third data type, that is Varchar2 data type. In SQL, the Varchar2 data type is used to store variable length character string. This means that the length of the data can vary up to a maximum specified length, and only the actual characters are stored without any padding or appendation of the spaces. So here the no appendation or no updation of the extra spaces will happen. Okay, that was happening in the case of char, so it's unlike the char. Varchar2 store alphanumeric characters, symbols and spacer characters up to specified length. Let's understand Varchar2 data type using real world example. So consider a database table, that is customer table, that stores customer information including the customer's full name and email ID. The full name and email ID could be represented as Varchar2 data type. First we'll create the customer table using this syntax, and after execution of this syntax we'll be able to see the table structure like this. Let's understand the table creation syntax first. So in the example, full name and email ID column is defined as a Varchar250 data type, indicating that it can store variable length string of up to 50 and 100 characters. Okay, this allows for flexibility in storing the names of different length without wasting storage space. For example, if you have a define Varchar250 column and insert the string hello into it, it will store as hello without any additional paddings. So here no additional padding of the spaces and no appendation of the spaces will happen. Okay, so we should be using Varchar2 data type when we expect data values in a column are of the variable length and contains the alphanumeric values along with the special characters. Okay, so Varchar2 is useful for storing text data where the length may vary, such as names, addresses and comments, and it optimizes storage space by only using the necessary amount of space for the actual data. That's why it is very much beneficial to use. When inserting data into this table, the full name and email ID values can vary in the length. Okay, let's see what type of data we can get under full name and email column. So we have this first syntax to insert some data into this table. So after execution, we'll see data is inserted like this in the respective columns. Okay, and we can observe the Varchar2 data, that is Bob Marshall, is inserted into column, that is customer name column, and bob12@example.com is inserted into email column. Likewise, we have another insert statement to insert another set of data. So after execution, we can see here the Varchar2 data, that is Ben Twins, is inserted into which column? Customer name column. And Ben98@example.com is inserted into email column likewise. And basically here the full name values Bob Marshall and the Ben Twins have varying length, but they both fit within the maximum length specified by the Varchar2 data type, and respectively their email IDs as well. Okay, so this allows for the flexibility in storing names, emails, etc. of different lengths without wasting storage space. So this Varchar2 is very much beneficial over Char in some cases. Okay, our fourth data type is date data type. Okay, so in SQL, the date data type is used to store date and time values. Let's understand date data type using the below real world example. Consider a database table named orders that store information about orders placed by customers. Okay, so one of the column in the table could be order date, which stores the date and time when each order was placed. Okay, so first we'll create the orders table using this syntax, and after execution this syntax, will see the structure of this table is created like this. So let's understand the table creation syntax first. The order date column is defined as a date data type in this example, indicating that it can store the date and time values. Okay, so when inserting data into this table, the order date values represents specific dates and times. This allows for flexibility in storing names of different lengths without wasting storage spaces. Okay, so let's see what type of data we can get under order date column. So first syntax, to insert some data into this table, we'll just execute this syntax. Okay, we'll execute this insert statement, and we can see, observe here, the date data, that is 27/04/23, that means 27 April 23 is inserted into order date column. And likewise, if we execute the second insert statement, what we will get? The date data, that is 9th of April 23 is get inserted into order date column. Okay, so basically here the order date values, that's 27th April and 9th April, represent specific points in time when the order were placed. Okay, the toDate function is used to convert string literals into date values according to the specified format, that is YY, MMDD, hours, minute and seconds. Okay, so let's take a note of below 2 points now. So this is the very important note we have to understood when we are working with this data, that is date data type. Okay, the first point is, in Oracle SQL, the date data type is used to store both date and time values. Okay, but when you view the data in a database tool or application, it may display only date portion by default. That means we are only able to see the date and not the precision of the time. And the second point says that to view both date and time portion of the date in Oracle SQL, you can use appropriate SQL queries. Okay, for example, this below query will display the date and time values stored in the order date column. So with the help of this query, the query mentioned in the snap, with the help of this query, we can get the date as well as the precise time as well. So we can note this point, and in future, whenever you require, you can make use of this query. So now we have fifth data type, that is decimal data type. Okay, so in SQL, the decimal data type is commonly used to store fixed point numbers with a specific precision and scale. Okay, the precision represents the total number of digits in the number, while the scale represents the number of digits to the right of the decimal places. So we have example, that is decimal 10 So what it says, precision of 10 digits, that is totally we have 10 digits, and out of this 10, 2 places after decimal points. Okay, so let's understand decimal data type using one of the example. Consider a database table name, we'll take a products, and that stores the information about various products including their prices. So one of the column in this table could be unit price, which stores the price of each product. Okay, so one of the column in this table could be unit price, which stores the price of each product. Since prices usually have to have a fixed number of digits to the left and right of the decimal point, the decimal data type is suitable for the storing them. So because price may vary with the numbers, that's why we can make use of this decimal data type to store them. Okay, so first we'll create the product table using this syntax, and after execution we can see the structure is created like this. And the example we have taken, inside we have mentioned unit price column is defined as a decimal data type with a precision of 8 and a scale of 2. That means total we have 8 digits and 2 is after the decimal. Okay, so when inserting data into this table, the unit price values represents the prices of the products. Let's see what type of data we can get under unit price column. So we have this first syntax to insert some of the data into this table. So after execution we can see decimal data, that is 29.99, is inserted into which column? Unit price column. And similar line we have second insert statement. So after execution we can see the decimal data, that is 99.95, is inserted into unit price column. Basically here the unit price values, that is 29.99 and 99.95, represents the prices of the tool and the gadget products. Okay, the decimal data type ensures that the prices are stored accurately with the specified precision and the scale. So with the specified precision and scale, if we require, then we can make use of this decimal data type. Let's move on to the sixth data type, that is float data type. In SQL, the float data type is commonly used to store floating point numbers with having the single or double precision. If I talk about the difference between the float and decimal in terms of precision, then I'll say that float is used for approximate calculations where precision may vary. Okay, and while decimal is used for exact calculation with fixed precision. Floating point numbers are approximate representation of real numbers and can store a wide range of values, including very large or very small numbers. Okay, let's understand float data type using one of the example. We'll take one table, that is temperature cal, that stores temperature data collected from various location. Okay, one of the column in this table could be a temperature, which stores the temperature readings. Since temperature value can vary widely and may include decimal fractions, the float data type is suitable for storing this temperature. Okay, so note here that the precision may vary in terms of temperature. That's why we are using float data type over which data type? Over decimal data type, because for decimal we require the perfect precision, and for the float the precision may vary. That's why we are making use of that decimal. We can making use of the float here. Okay, so first we'll create the temperature cal table using this syntax, and after executing this, the table structure will create like this. Okay, so if you understand the syntax, then the temperature column is defined as a float data type here. This allows it to store temperature readings with a single or double precision. It depends on the implementation. So when inserting data into this table, the temperature values represents the temperature readings. So we'll see what type of data this temperature column contains. First we'll execute this insert statement, and we'll see after execution the float data, that is 62.5, is inserted into this column, that is temperature column. And likewise, if we have another set of insert statement after execution, we can see the data, that is the float data, that is 71.9, is inserted into temperature column. So basically the temperature values, that is 62.5 and 71.9, represents the temperature readings in degree Fahrenheit for the location New York and Delhi respectively. Okay, and the float data type ensures that the temperature readings are stored accurately with the appropriate precision. Okay, next take a seventh data type, that is timestamp data type. So first point, in SQL the timestamp data type is used to store date and time values with fractional seconds precision. Okay, so it can store a specific point in the time down to nanoseconds as well. Let's understand the float data type using one of the example. Consider a database table, that is event info, that stores information about event occurring in a system, that is log in and log off. Okay, one of the column in the table could be event timestamp, which stores the date and time when event occurs or event occurred. The timestamp data type is suitable for storing this timestamp with high precision. When we require the high precision, we can make use of this timestamp. Okay, so let's talk about the difference between timestamp and date data type in terms of precision. Okay, so timestamp data type provides more precision timestamp information, including both date and time with a fractional seconds, while the data type stores only the date without any time component. Okay, so that is the difference between time and date. When we require the more precision, we can make use of the timestamp, and when we require only date part, then we can make use of date data type. Okay, the choice between them depends on the specific requirements of the appropriate depends on the application and the level of precision needed for storing data and time information. Let's move on and create the event information table using this syntax. And after execution, we can see structure is created like this. And now let's understand the syntax for this. So event timestamp column is defined as in timestamp data type. So this allows us to store precise timestamp for each event. So when inserting data into this table, the event timestamp values represents the timestamp of the event. So we'll see what type of data this event timestamp column contains. With the help of this first insert statement, we can see how the data is getting inserted. So after execution, we can see the timestamp data that is along with the date and precise timestamp is inserted into column, that is event timestamp column. Likewise, we have another insert statement to insert the same set of data. Okay, so after execution, we can see the timestamp, that is 6th April 2024, along with appropriate precision time is also inserted into event timestamp column. Okay, basically here the event timestamp values, that is the date with the particular precision, and second value also this date with some precision represents the timestamp of the login and logout event. Okay, the timestamp data type ensures that these timestamps are stored accurately with fractional seconds precision. In conclusion, understanding the different data types available in SQL is essential for effectively designing and managing the databases. So by selecting appropriate database for each column in your database table, you can ensure the integrity, optimize storage, and improve query performance as well. Thanks for watching this video. If you like the video, please hit the like button and don't forget to subscribe the channel, and also share this video with your friends so that they can also learn the new things. See you in the next video.